Today's topic is velocity. And many of you may say, wait a minute, didn't we already learn about velocity? And the answer to that is actually no, we did not. What we did is we learned about speed. And you'd be forgiven for thinking that speed and velocity are synonymous. So many people, so many times you're going to hear speed and velocity being used interchangeably. So today I want to make sure you understand the difference between the two and why one is important in some cases and the other is important in another case. So we have speed, which we already learned about, equaling distance over time. And we said speed measured how fast an object went. And we said that speed could be measured in something like meters per second, miles per hour. Okay, so what gives? What's different between speed and velocity? Well, it turns out that velocity is what is known as a vector. And if you guys ever saw the movie Despicable Me, there's a character whose name is Vector. And when he introduces himself, he tells you exactly what he means by the term vector. So if you listen carefully, he will tell you the definition of vector.
Villain loan go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
So a vector is some sort of measurement that has both a magnitude, that is a size, and a direction, okay? So when we're talking about speed, a speed doesn't need a direction. In fact, a speed doesn't have a direction. You just say, I'm going 60 miles an hour, and that's good enough for the term speed. But when you use the term velocity, you must tack on the direction that you're traveling. So for instance, you might say, I'm traveling 60 miles per hour north. By throwing the term north in there, you've added a direction, and then you are describing what is known as a vector, and that vector is called velocity. There's lots of other vectors that will be coming across throughout the year, but this first one is velocity. So how do you indicate direction? Well, we already said it could be something like north, south, east, or west, but oftentimes, when we're talking about just one-dimensional motion, we're going to indicate direction with a plus or a minus. So if you watch these two videos, the first one we have a firework getting shot up, and when it's moving up, you might say the speed is 20 meters per second. On the way back down, you would say the speed is maybe 25 meters per second. Negative. So the very fact of putting a plus or minus in front of your number changes it from a speed to a velocity. It's helpful to put it plus in there even if it's understood to be plus. That way it lets the person know that it's moving up, or a negative lets you know that the object is moving down. If instead you're dealing with horizontal motion, like the little ghost from Pac-Man, you could see him moving right, and that would be maybe 3 meters per second. Positive, because he's going to the right, and then you saw him take off in the opposite direction a little faster, so maybe negative 4 meters per second. The negative indicates he's going left. It does not mean he's in the negative numbers for his position. It indicates the direction that he's moving. So even when he was in positive numbers, the numbers were getting lower, so that would represent a negative direction or a negative velocity. Okay? Positive could mean right, or positive could mean up. Negatives can indicate left, and negatives can indicate moving down. So for one-dimensional motion, it's easy to specify a direction with just a plus or a minus. Okay, so how do we deal with our squirrel? Well, instead of writing speed, we're going to use the letter V for velocity. Instead of writing distance, we're going to write it as delta x. Later, we will see that this is called the displacement. It might be helpful to write it down now, even though we're not going to focus on it too much. We can just call it delta x, but it's the displacement of the squirrel, his change in position divided by the time. So you can see his starting position is about 0.5 meters. His ending position is going to be about 2.5 meters. And his displacement would just be 2 meters, positive, because he went up by 2 meters. Had he been running to the left, his x values would have been decreasing, and then his displacement would have been negative. If he had run all the way to this pole and came back again, his displacement would have been 0. Okay, because he would have started and ended at the same spot, and his change in position would have been 0. Okay, so delta x again is not distance, it's the change from where you start to where you end. In this case, it's positive because the numbers are going up. Again, you would divide by the amount of time it took, and we get our squirrel going half a meter per second. Okay, so it's a lot like speed, but now it also indicates a direction of travel, which in some cases is very useful. Okay, you'll hear velocity used in baseball a lot. So when South Jersey native Mike Trout hits a ball, hits a home run, they may tell you what's called the exit velocity. And the exit velocity actually includes two parts. It includes a how fast and a direction. They specify direction by an angle because it's not going perfectly horizontal or perfectly vertical. So another way of specifying direction is with an angle. The combination of how fast plus the angle makes it a velocity. Okay, so here's a picture again of Mike Trout hitting the ball. And if you were going to draw it, you draw an arrow showing the direction and the speed. The direction again is indicated by the angle. Okay, so here's an example where velocity is way more important than speed. So here's a picture of Delsea Regional High School. I put a little X on top of my classroom. I have a little drone up on my roof, and I'm going to send the drone off. And I'm going to have it fly away from Delsea at a speed of 10 meters per second. I want to know where the drone's going to be 100 seconds later. Okay? So 10 meters per second for 10 seconds gives me 1,000 meters. But that doesn't really tell me where the drone ends up. All it tells me is if the drone flew off in a straight line, it could be anywhere on this dotted circle with a 1 kilometer radius from my classroom. In order to specify exactly where the drone's going to end up, instead of a speed, I should give a velocity. So if you're trying to predict not just how far it went, but where it actually is, velocity is more important than speed. Okay, so if it was heading east, this is how you'd write the velocity. 10 meters per second east. By throwing the E on there, east, the direction, you've turned the speed into a velocity. And again, you can show it with an arrow. An arrow showing that it has both magnitude and direction. A size and a direction. Oftentimes with airplanes, they will give what's called the bearing of the airplane. Sometimes it'll be called heading, although that is slightly different. Okay, but they'll write it like this. How fast, and then they'll give the angle but they'll specify that this angle is 30 degrees east of north. So the plane is heading 30 degrees east of north. If instead they had written it that would mean the plane was 40 degrees west of south. Okay, and that is one standard that they sometimes will use when specifying which way the object is moving. Again, velocity is both a magnitude and a direction. How you specify the direction, there's no consistency, so different people will do it in different ways. Okay, I'd like you to use a program to show me that you can actually calculate velocity, so it's not really that bad. You're going to have an airport with a little radar station, and as the radar pans the sky, it occasionally will pick up the airplane and it will show on your display. So as it goes around, you're going to be looking for the airplane. You never know where it's going to be. And there it is. Just like on real radar, it will eventually fade away, and on the next sweep, it will get picked up again. Okay, let it go around a few different times. You'll see at the bottom, it tells you how much time has passed since the plane has left the airport. And you'll use that time to figure out the velocity. So to get the velocity, you need to know how many meters it traveled. And you'll see this is 5 kilometers, 10 kilometers, 15, 20 kilometers. You want to go by the nose of the airplane. Okay, so this is maybe 21 kilometers. And it took 87 seconds to travel. So you divide those two, and that will tell you how fast it went. That's not velocity, that's speed. So then you have to get the heading or the bearing, and that will be based on these markings here. So 180 is here, 0 degrees is east, 270 is here, 210, 220, 230, 240. This guy is maybe 218 degrees. Again, measured from the 0 on the east. Some people will put the 0 on the north. It doesn't really matter. So long as you stay consistent with this problem, with whatever problem you're working with. Okay? So to find how fast, distance divided by time. To get the heading, you look at where it is and make your best guess estimate. I hope this explains the difference between speed and velocity. Velocity is a vector, it has direction.